Welcome to Voice Bootcamp, a global name in unified communication. Hello, my name is Faisal Khan, CEO and founder of voicebootcamp.com. In this self-study kit of CCIE Collaboration version 2, we're going to talk about Cisco Unified Border Element, or often known as CUBE. So CUBE happens to be a bridge that interconnect voice and video connectivity between two separate VoIP networks. It was designed as a traditional voice gateway, except that it is a replacement for physical voice trunk with an IP-based connection. The traditional voice gateway usually used to connect a VoIP network to a telephone companies using a circuit switch connection such as T1, E1, or PRI. CUBE, on the other hand, can terminate and originate signals based on either H.323 or SIP and media stream via its device. Now, CUBE extends the functionality provided by the conventional session border controller (SBC) in terms of protocol internetworking, especially on the enterprise side. Now, one of the advantages of CUBE is that you can do protocol signal internetworking, meaning that one side of your network could be H.323, while the other side could be SIP. Media internetworking, dial tone frequency, fax modem, codec transcoding, these are all part of CUBE features. It has the ability for address and port translation, privacy, and topology hiding. CUBE can provide billing, call detail records, normalization, as well as QoS. Now, protocol networking is possible for the following combination. You can send call from H.323 network to SIP, or you can send a call from H.323 to H.323, or SIP to SIP. CUBE can provide a network-to-network demarcation interface for signaling networking, media networking, address, and port translation, so that you can hide your internal network from an external by forcing every traffic to go through the CUBE router. Now, CUBE is used by the enterprise, small to mid-sized business, or to interconnect PSTN, SIP-based PSTN. A lot of service providers that are providing some sort of SIP trunk these days probably often use the CUBE to establish that. Now, CUBE is use either SIP or H.323. SIP happens to be signaling communication protocol, which is used for controlling multimedia communication session, such as voice, video calls over the internet protocol. Now, you can either use SIP trunk or H.323 trunk in order to facilitate the connection between your private branch exchange and to any other VoIP network. So here's the example: your call manager via the CUBE to SIP trunk to your service provider. A typical deployment scenario for CUBE, which provide improve efficiency of interconnection, simplifies PSTN interconnection with the IP to end-to-end. So you could have an IP phone to call manager, to a SIP to the CUBE, and from CUBE to a SIP trunk to a service provider. It enables rich media services to your employee, customers, and partners. Through this method, you could pretty much have customers calling you over an IP network. You could provide, let's say, a SIP-based phone on your employee's smartphone, and they can then use the data networking on their phone to communicate with your infrastructure. Now, the configuration workflow for SIP is, first of all, you must enable CUBE, and then configure any trusted IP address for toll fraud, such as a list of IP addresses that are allowed to pass through this router for VoIP traffic. Then you check if the incoming call number patterns is identical on both sides. If it is yes, then configure to make the number pattern unique. If no, then you configure all your inbound and outbound dial pairs for both sides. You configure other dial pair related controls such as DTMF relay, payload type, codec, etc. Configure your binding for your SIP traffic for both media and control on both sides. Define any SIP profile for changing any headers or replacing any headers. And finally, configure other call signaling protocol such as registration or authorization, etc. Now, one of the things that Cisco introduced in CCIE Collaboration version 2 is a cloud service router, CSR. Cisco CSR is a cloud service router called 1000V. Happens to be a virtualized router which runs on VMware. Cube Cube is supported on a CSR 1000V router, which is often known as virtual cube or vCube. Now, vCube enables traditional cube feature to be deployed on a cloud-based data center, whether it is internal or Amazon or let's say Microsoft Azure. A virtual cube support most of the features that are available in normal cube, except anything related to media plane, such as DSP related features or transcoding or DTMF Internetworking are not supported. So these are some of the features that are not supported if you are going to use the CSR 1000V router. Now, high availability in virtual cube is provided using a redundancy group infrastructure configuration. HA is between two virtual cube router that either running on the same host or across a different host in your VMware, connected through some sort of switch. So for example, you could have two virtual VMware ESXi hosts, one running the primary cube, one running the secondary cube. The CSR 1000V happens to be a box-to-box redundancy option that uses the redundancy group infrastructure to form an active and a standby. So you must configure one router to act as an active, other one as a standby. So the active and standby pair will share the same virtual IP address that continually exchange status messages. Virtual cube will then provide session information, which is checkpointed across the active and standby pair of the routers, enabling the standby router to take over all virtual cube processing responsibility if the active router is out of services. So enough checkpointed are state information of the past between them, so that the standby router can take over the control pretty much right away as soon as the active router goes down. However, standby router will send and receive all redundancy information such as protocol, packet, configuration, keep alive, peer status, etc. But the call that are in transit in state at the time of failover will be disconnected though. Now, CSR v1000 can run on VMware ESXi. Now, in our environment, we have three routers right here. You can see these are my three CSR v1000. This is running on host 202. Site B is running on host also 202, but site C, I believe, well, that is also for some reason on 202. It's probably because of the clustering that I'm doing. But if you look at the routers, virtual router HQ, if you double click on it, and you should be able to see pretty much what a Cisco router looks like on a console level, so router config T, and then you configure whatever the services you want. Now, to configure, so as I said, the v1000 will run on 1000V, which runs on ESXi, happens to run on 86 base CPU. ESXi host will be connected to one port in your physical switch. So in our case, our host is always connected to 6509 switch, and it provides and ESXi itself will provide a virtual switch which allows all the virtual machines to communicate within the ESXi server itself. So if I look at my VMware, between these three I can communicate all day in and out without having a physical switch connected to it. It's because the VMware itself provide a virtual switch that can do the switching between them. So to configure high availability, you will log in, go to enable mode, configure terminal, then type the command redundancy mode none. Now, of course, it may require license. So for example, if I want to configure redundancy here, so certain features, remember, Cube will require a licensing mode. Now, as you can see, I cannot type the mode command. and it is most likely because of the licensing issue. So you'll type mode none, application redundancy, group 1 for provided name, priority, failover threshold is 75%. So if it is low to 75, then it will kick in, the failover will kick in. Control protocol will go through the gigabit Ethernet 0/1/2, and the data will go through this particular interface. So this is how you create a redundancy group. And then you go to voice service VoIP, you say mode border dash element, allow connection SIP to SIP, and you associate the voice service to the redundancy group 1, and that is the group number that you configure right here. So that's basically how you configure high availability between the two ESXi hosts. Now the state switchover for virtual machine is that stateful switchover occurs when active router crash or reload happens. The switchover from active to standby router will occur when the active router processor fails or when keep alive messages between the active and standby router is lost. So of course, when the router crash or reload, standby will take over right away. But if the active to standby router, if the keep alive messages between the standby and active router is lost, then of course the standby router will take the active role. Standby router will send route group redundancy group infrastructure keep alive message to active router. So on every 100 milliseconds is going to send the RG infra keep alive message to the active router and expect an acknowledgement within 100 milliseconds as part of the default timer. If there is no acknowledgement of a keep alive within the 100 milliseconds, then the standby router will immediately send a message to active router saying, hey, are you there? Are you there? So in order to check the status health. If there is no keep alive message response, meaning that there is no acknowledgement for site A, the standby router or active router, standby router will declare that active router is dead, and therefore standby router will then take over the active router role. Now in media, the virtual queue media performance will depend on the underlying VM platform, which consistently providing packet switching latency of 5 milliseconds or less. The jitter and latency value which will be observed in a virtual cube is exactly the same value that is running on a physical or hardware platform with the recommended hardware configuration. The virtual cube is enabled with the APPX license or AX license packages, which we will talk later in the different chapter. The AX license package will provide access to all the features that are supported within a virtual cube. When license is installed, the virtual cube related CLI commands such as voice, dial pair configurations are now visible. Now as you can see from here, if I try dial-pair, still enabled, so voice service VoIP, let's say mode border element. Okay, you say you need to save and reload the router for this configuration to take effect. So again, certain features are available without the license, certain features will not be available without the license. Now, media path. Media path feature allows you to configure path taken by media after a call has been established. There are three types of media path you have: media flow through, media flow around, and media anti-trombone. A media flow through, where media path mode, where media and signaling packet will terminate and originate from the cube. In this scenario, all traffic will go through the cube router, so there is no direct point-to-point configuration between the endpoint. In this case, the cube is the active participant of the call, and the mode is recommended when you're connecting to the outside enterprise so that you can hide your internal network. Video codec are not supported when you configure your network to use media flow through, and because of that, it also does not support delay offer to early offer for audio and video calls. To configure a media flow through, you can configure two ways: dial pair level or global level. In a dial pair level, you type go dial pair voice 130 VoIP, then you say media flow dash through. On a voice service level, you say media flow dash through. The difference between them is the dial pair will only affect that particular dial pair, whereas a voice service VoIP, it will affect all the dial pairs that you have. So that can cause some problem if certain segment of your network does not require media flow through services. Media flow around is the opposite, where the signaling packet will terminate on the queue, but the RTP or media traffic will be between the endpoint, directly between the two devices, as you can see right here. So to configure media flow around, same thing. You can do a dial pair level or global level. Now, there are cases where you can, you know, call someone and they forward the call or they transfer the call, and you may end up getting into a loop. Well, in that scenario, media anti-tromboning is a method or media path mode that allows Cube to detect and avoid loop created by call transfer or call forwarding. For example, I forward the call to you, you forward it to me, and I again forward it back to you, and we go into call forwarding loop. The loops are restricted in a SIP signaling path and removed from the RTP path, from the RTP media path. User agent may initiate a call forward and call transfer that are sent toward the queue as a new SIP invite dialog. SIP will consider the original call and the forwarded call as a separate, unrelated call. Now, the media tromboning allows Cube to detect any relationship between the call and resolve the media loop by sending an SDB packet back to the caller. Now, when this mode is activated, Cube does not perform any supplementary services such as handling refer-based call transfer or media services such as secure real-time transfer protocol. Now, anti-tromboning does not work if the one call leg is a media flow and other one is media flow through. It has to be the same. At the same time, it also does not support if one call leg happens to be SDP pass-through, other one SDP normal. And H.323 is not supported. So this is an example of media anti-tromboning. Now, to configure this is pretty straightforward. Same power process, dial pair level or global. You just type the command media flow-trombone. Now, SIP binding, which is very important. When you configure SIP on a Cisco router, all the port on that router's interface are open by default. The source address of a packet going out of the gateway is usually never determined. SIP protocol or VoIP layers always depend on the IP layer to give the best local address. The best local address is usually the outgoing interfaces. SIP signaling and media path can advertise the same source IP address on the gateway for their certain application. Otherwise, that application may not work. So the best local address was then used as a source address for signaling and media traffic. To achieve that, you use the bind command. Bind command allows you to configure the source IP address of a signaling and media packet to specific interface or IP addresses. When you do not specify bind command, or if the interface is down, the IP layer still provides the best local address. Now, what happens when you do not have bind command defined or different state of the bind command? It's because the bind command can be applied globally or a dial pair level. When it is applied globally, when no bind command is applied on a global level, so the best local address is used when based on all the outbound interfaces. Only one SIP listening socket with a wildcard source address. If the global bind address is used, if it is configured on globally, then the global bind address used in all outbound SIP messages. Only one SIP listening socket with a global bind address will be activated. But what about if the bind command is not configured globally, but it is configured on a dial pair? In that case, dial pair bind address is used in outbound SIP message of that particular dial pair. The remaining SIP messages use the best local address, which could be whatever the outbound interface. One SIP socket with a wildcard source address, an additional SIP listening socket for each dial pair, each different dial pair bind listening on that particular dial pair bind address. So if you have two dial pair with a SIP bind command, then that means there will be two listening socket, one for each, one for one with the wildcard source address and one for each dial pair. So the global bind and a dial pair bind. The dial pair bind address is used in an outbound SIP message. The remaining SIP message will then use the global bind address. One socket open for global bind address, and additional socket will be open for each dial pair that has a bind command. Now what happens if you bind it to an interface and that interface is down? If you shut down with or without the active call, the TCP, TLS, and UDP socket listeners are initially closed. Socket listener receive datagram address to those sockets. Then the sockets are open to listen any IP address. If the outgoing gateway has a bind command enabled and has an active call, the call becomes a not one-way call with a media flowing from the outgoing gateway to the terminating gateway. Dial pair bind socket listener of the interface are then closed, and the configuration turns inactive for all the subsequent SIP messages. Now what happens if the interface is not shut down without any active call? Again, TCP, TLS, UDP sockets are initially closed. Sockets are open, bound to IP address set by the bind command. Socket will accept packet destined for the outbound address only. So if you receive a traffic with any other address, it's not going to accept it. The dial pair bind socket listener of the interface are reopened, and configuration turns active for all subsequent SIP messages. No shutdown, but with active call. Again, in this case, TCP, TLS, UDP are initially closed. Then the socket are open to listen to any IP address, and the dial pair bind socket listener of the interface are reopened with the configuration turns active for all subsequent SIP messages. Now the bound interface of IP address is removed. What if you remove it for some reason? Again, all the socket listener will be initially closed. Then they're reopened again to any address because the SIP address has been removed. The message is printed on a state of the IP address that has been deleted from the bound address. If the outgoing gateway has a bind command enabled, has an active call, then the call becomes a one-way call with the media flowing from the outgoing gateway to the terminating gateway. And of course, dial pair bind socket listener of the interface are then closed, and configuration will then turn on for all the subsequent SIP messages. The physical cable is pulled on a bound port, or interface layer goes down. Again, initially closed, socket are reopened and listen to any address. When pull cable is replaced, the result is documented from interface that are not shut down. All the bind socket listener for the interface are then closed. Configuration will turn inactive for all the subsequent messages. Now if the bind interface is shut down, or its IP address has changed, or physical cable is pulled while the SIP call is active, the call becomes a one-way call with the media flowing in one direction. The media flowing from the gateway where the change or shutdown took place to the gateway where no change occurred. Thus, gateway with a status change no longer receive any media. The call is then disconnected, but disconnected messages are not understood by the gateway with a status change, and the call is still assumed to be active. If the bind interface is shut down, dial pair bind socket listener of the interface is closed. If the IP address of the interface is changed, socket listener representing the bind command is opened with an available IP address of the interface, and configuration will turn active for all the subsequent messages. So to configure bind command, you go to voice service VoIP, type SIP, click bind control source address fast Ethernet. That is your global level, or you can define control to bind to a specific interface, or media to be bind to a specific IP address. You can configure bind command per dial pair level right here, or like previously through globally. This is the global configuration. This is the dial pair configuration. All right, so CUBE is the next generation gateway. It provides SIP to H.323 protocol Internetworking, support media address port translation to hide the internal network, and media can flow through or flow around depending on what is situation you need. At any time you're connecting to an enterprise outside, always use media flow through. Loop can be avoided using an anti-tromboning. So that's pretty much it for overview about CUBE protocol. There will be more discussion of CUBE in the further chapter. Thank you for watching this video, and I will see you in the future video.